So as Mike mentioned, I'm from Microsoft, and today I want to tell you a story about one interesting Windows feature our team pen tested a year ago. The feature is called Speak for Me. It is an accessibility feature, and it allows people with progressive voice disorders to capture their voice before it is gone. So I want to start with a short demo. I would like you to meet Brian. So unfortunately, Brian lost his voice, but fortunately, he was able to capture it using the Speak for Me feature. And Brian will communicate to his wife first using the generic robotic voice. And after that, he will communicate using the Speak for Me feature. So let's take a look.
So, Brian, today we're going to play a newer version of your voice. And I'm hoping when you hear this, and when you hear this, it's going to remind you a little bit more of what he sounded like beforehand. So you just choose any phrase, and then I'll play it on here as well.
Hey, beautiful people, I am so happy to be with all of you.
All right, let me type it out.
Hey, beautiful people, I'm so happy to be with all of you.
Dang!
Hey, Christine, I love you.
Oh my goodness! I can't believe that, right? Like, that's really crazy.
So to use this feature, you first need to train it with your own voice. So let's take a look how this happens. So first, user needs to record random text messages using their own voice.
The music is too loud. I can't concentrate. The coffee was too bitter, so she added a spoonful of sugar.
Okay, so now all the training data is sent to the cloud. And now the model is being cooked in a cloud oven. You need to wait for an hour. And finally, you can download the model to your local Windows machine. And you can try it out. You can type text and hear it with your own voice.
Hello, I am excited to see how I sound. Love to use this voice to communicate with others.
Okay, so let's take a look at some of the features this infrastructure offers. So first of all, it is integrated into Windows ecosystem. It can be configured as a virtual microphone and used seamlessly as part of Teams or any other communication apps. And even though it was originally intended for people with disabilities, it can actually be used by everyone. And this feature, it can enable some really powerful and at the same time dangerous scenarios. So, for example, in our era with different agents and virtual co-pilot personas, it's not hard to imagine how this feature can be used to answer calls on your behalf, to make calls on your behalf, to participate in a meeting on your behalf. And this can be done even on scale by a swarm of agents. So this feature can be both a blessing and a curse. And since we're talking about security research here, we will be only focusing on the bad stuff. So just to highlight the potential damage and the potential dangers of features like that, we made this security research 1 year ago, but you can see some recent headlines. The situation since then only got worse. And I wanna share a personal story on this regards. I don't know what the situation is in Canada. I come from Israel, and in Israel there is an epidemic. You could call it a scandemic. There is an older Russian-speaking population that is targeted by malicious actors. And some people I know receive as much as 5 scam calls a day. I have no idea why they target specifically Russian-speaking population. Maybe because it is cheaper to open a scam hub in some Russian-speaking countries. But anyway, one day my mom receives a call, someone calling her, pretending to be me, and telling her that I got into some serious car accident and that I need cash urgently to sort things out. So luckily, my mom remembered my previous guidelines. She immediately hung up the phone. She called me. And needless to say, I wasn't involved in any car accident and didn't injure anyone, at least not that specific day. So I really doubt that in this particular case, they went as far as to deepfake my voice. I'm not that important, and I'm not that rich, unfortunately. But in some cases, they really do it. And in many cases, they are smart enough to switch the phone number using some telephony loopholes so that someone could actually call your family with your voice and with your phone number. And it's really a scandemic in my country. So at this point, you might wonder, well, if this is a Windows feature, how come I never heard about it? And the answer is simple. The story I'm going to tell you is a story about feature that never happened. After our security review, some back and forth technical discussions, it was decided to not move with this feature because of its risks. I personally do hope that it will be released at some point in the future. Today, unfortunately, the defensive technology is just not there. And the story I want to share is why it isn't, what were the security risks that were involved with this feature, and what did we learn in the process. But first things first, before we go any further, a page of some shameless self-advertisements and a word from my sponsor. So my name is Andrei Markovic. I'm part of Storm security research team. Our team performs internal audits for Microsoft products that power the infrastructure for AI models. Our specific team usually looks at products that run on Microsoft hardware and software at customer premises, the so-called on-prem scenario. But sometimes we also look at Windows client devices, like, for example, with this specific feature. So some areas of my personal interest and personal and professional interest, confidential compute, all the stuff that runs before the main OS boots, bootloader, secure boot, stuff like that. Cryptography, AI model security, obviously. I consider myself beginner-level calisthenics enthusiast, and I am a father of 2 kids and a foster father to a cat. This is our agenda for today. We already started looking at how this feature looks from the outside. Now let's take a look at the internal high-level architecture. This feature uses a lot of existing components on both the local client Windows side and also components on the Azure cloud infrastructure. So the new components are marked with orange. So let's go from left to right. So first you have the Speak for Me desktop client, which presents the graphical user interface, and it also manages the models locally. This client app communicates to the Speak for Me backend via Azure APIM gateway, which provides some protection for gateway endpoints. It's one of the existing Azure APIs. So you can manage IP filtering, rate limiting, and stuff like that. The Speak For Me backend talks to the CNV service. CNV stands for Custom Neural Voice. And this is the service that actually trains your model. The model is downloaded locally and managed locally on the PC, but there is also a backup on the cloud side, which is managed via Azure Blob Storage. Now let's zoom into the client side. So Speak For Me user interface leverages the existing accessibility feature in Windows called Text-to-Speech SDK. And if you're not familiar with it, this is just an SDK to play text messages with generic voice. And Speak For Me was supposed to extend this SDK with custom voice models. So the model is downloaded and stored on the device in an encrypted form. And the encryption key is encrypted on its own by the DP API Windows crypto library and also stored in encrypted form on the device. We already discussed the potential dangers of this technology. Now let's take a look at the threat model that was envisioned by the product team. So the main concern of the product team from the very beginning was two things, actually, which boil down to just one, which is the abuse of this technology for the production of deepfakes and potential harm to Microsoft's reputation. So to prevent this, they focused on two components, on local model storage and on the framework responsible for model training. And they deployed a couple numerous mitigations on both the local side and on the website. So let's discuss some of them. On the local side, as we mentioned, the model was encrypted at rest and during transit. And there was also a dedicated watermark mechanism that was embedded into each generated voice. And basically, this mechanism was supposed to provide you with a way to distinguish a genuine voice from the generated one. On the website, so the local app was supposed to present random text messages to the user, and the user was supposed to speak out those messages with their own voice. And the website was responsible to actually make sure that those voice samples corresponded to the actual text that the user was supposed to read aloud. This was done using, again, one of the existing Azure APIs. There is an Azure service which translates voice back into text, and after that you can make sure that the text is really what you expect it to be. And there was also, the user was also required to record a special predefined consent message. And the website was supposed to make sure that this consent, the voice used for this consent message, is the same voice that was used to record the voice samples. So on the next couple of slides, we're going to discuss briefly the specific implementation vulnerabilities we discovered in the code, both locally and on the website. We will not dwell too much on this stuff because those are not the important problems, and those problems were not the reason why this project was canceled, and we want to get to the bigger problem. So let's take a look. So let's start with the client side. So as I mentioned previously, the model was managed using the speech-to-text SDK. which was responsible for both the encryption and also for the inference part. So the SDK was supposed to load this model into memory and then inference it. And this SDK, previously it was used only for generic voice models, and it provided some basic level for obfuscation for those models because those models are really not interesting to anyone. So there was no requirement to provide a more solid protection. And basically the same mechanism, the development team reused it to protect the custom voice models as well. And of course, this was totally unacceptable because the custom voice models are much more sensitive than the generic ones. And the same goes for watermark mechanism. So the watermark, the way it worked, for each generated voice, there was a hidden voice audio frequency that was embedded into this voice. This frequency could not be heard by human ear, but using a special SDK, you could easily detect it. So this watermark mechanism was supposed to sign the sample using random key, and the mechanism used pretty weak random number generator with constant seed. On top of that, there were two additional problems. So there was no certificate pinning for communication with the backend side and also for model package verification. And the model also was, even though it is just a binary blob of data, it was distributed and installed on a machine as MSIX executable package. And basically using those two vulnerabilities, if the web side was compromised, or if any of the dozens, if not hundreds, root certificates you have on your OS were to be compromised, this could mean remote code execution on millions of devices. On the website, before we go to the website, let me just emphasize again, why is it so important to train the model and present the user with random voice samples? Because if those samples were not random, you could just leverage this whole infrastructure to train it on some arbitrary person for whom you happen to have the recording. So you could just record your neighbor, or you could go to YouTube and use some recordings of any public persona, and then you could leverage this framework to train a model. So on the website, the first vulnerability we saw was with the backend endpoint that was responsible for receiving the training data. So one of the parameters this backend received from the app was the actual reference text that user was supposed to pronounce. And basically what attacker could do, they could use the backend directly, and instead of using the application, and they could simply supply this reference text parameter. So basically you could do exactly what was supposed to be prevented. You could train the model using any voice sample as long as you supplied the corresponding text via this parameter. Additionally, there was also path traversal vulnerability in another parameter, in a parameter responsible for the audio sample itself. So the audio sample, among others, it contained the path to that audio sample. And basically, attacker could, because there was no check for data path traversal, attacker could supply something like that, and they could access data, both training data and the model of any arbitrary user of the framework. And this was possible because all the data, including the model, were stored in one global blob storage, which was separated only by different folders. Different users were separated by different folders with no additional permission checks. And if it wasn't enough, the encryption key for the model was stored along the model itself. And needless to say that you usually want to use Azure Key Vault to store sensitive keys. So this slide summarizes all the vulnerabilities. We didn't discuss the last one, so again, we won't go into much depth for this vulnerability, but basically it allowed an attacker to take control of the backend Windows push notification service and thus send notification to any client application, to any Speak For Me client application, either for a specific user or to all the users, and trigger some behavior inside this client application. At the moment of the review, the only behavior that was handled inside the client application was handling the request to delete a particular blacklisted model from the device. And this vulnerability could mean that an attacker could perform denial of service attack either on a particular user or cause a global outage of the whole infrastructure. And one last vulnerability, I put it in a separate slide because it's a peculiar one. So this feature was supposed to be completely free for the end users, but for Microsoft it costed money. And to prevent abuse, each user was limited to have only one voice model. Users were not allowed to have multiple voice models, which pretty much makes sense. You don't have many voices, you only have one. But there was no prevention from user to create and delete this one and only model in a loop. And you could do it in scale. So you could create multiple MSA accounts, and each account would be associated with such a model. So attacker could cause substantial financial harm to Microsoft using this vulnerability. So to summarize, we found issues in pretty much every component in this whole infrastructure. But again, this is not the bigger problem. All the vulnerabilities that we mentioned previously could be easily fixed, and this is part of the process. Many teams in Microsoft, they go through security review, and teams like mine advise on how to fix security issues. But there was also a bigger problem. So let's talk about two bigger issues with this project. So first, let's talk about the runtime protection. Encryption at transit and encryption at rest are cool, but what about runtime? You could encrypt the model with any modern cipher you like, including the quantum-resistant ones. But at the end of the day, the model needs to be loaded into some framework that will actually inference it. And this framework will have to receive this model in a decrypted state. And in our case, this whole application, including all the SDKs it uses, it runs just as a regular user app application. So it means that any malware that runs on the same machine could simply dump this model from the memory at the time of the inference. And this also applies to the watermark mechanism. Again, you could make it much more sophisticated, and you could make it in such a way that the keys would be truly random, the keys that sign those watermark samples. But if this whole thing, including the watermark mechanism, runs in a regular user space, malware can simply disable it before it ever happens, or vice versa. The malware can force the application to apply this watermark mechanism to arbitrary voice sample, including genuine voice. So we could, one of the ways to raise the security bar would be run parts of this application or maybe the whole application inside kernel, or maybe as a special PPL process in Windows. And this could raise the bar a little bit. But let's be honest, with the abundance of privilege escalation vulnerabilities that gets discovered every other day, of course, we fix them the moment we know about some privilege escalation vulnerability in Windows, we fix it. But many vulnerabilities are still unknown and being used by some shadow groups. And it's not such a big deal to find privilege escalation vulnerability in either in Windows infrastructure or in any of the third-party kernel drivers that run in Windows. So this would not raise the bar significantly. One way to raise the security bar a little bit higher is to use something called virtual-based security. So virtual-based security introduces concepts like secure kernel and virtual trust layers. And basically, it allows you to run, so all the regular stuff continues to run in VTL0, but you can run more sensitive stuff in VTL1. And by the way, VBS supports up to 16 VTLs. And the idea that higher level VTLs are protected from the lower level VTLs. So VBS was around since 2015, 2016, but initially it was used only for internal Windows stuff, such as biometrics or LSAS. And it was opened to both to third-party Windows, both to first-party Windows developers, like Microsoft teams, different Microsoft teams that develop applications internally for Windows, and for external developers using the VBS enclaves. So basically, since 2024, anyone could use the VBS enclave SDK and write their own trustlet that will run inside VTL1 in secure mode. So what we can do, we can place the Speak For Me app inside VTL1, and it will give you hypervisor level protection. So as I mentioned, VTL1 and higher VTLs are completely isolated from the main OS running in the VTL0. And to raise the security bar even higher, you could seal the model encryption key inside hardware, inside trusted platform model hardware. And you can build the design in such a way that this key would be only unsealed to the trustlet running in VTL1. And this would, by the way, ensure that the model is tied cryptographically, a particular model tied cryptographically to a particular device. So even if you extract the model from the device and you steal it, you won't be able to decrypt it because the key is still inside the hardware, inside the TPM. One thing to note here is that developing trustlets is much harder than developing usual applications because this infrastructure is isolated. You could tell that it is kind of separate OS, kind of, not really, but it is isolated and you don't have all the usual SDKs that you have when you develop apps to run inside regular Windows VTL0. One additional thing that is important to mention regarding VBS enclaves, so I was talking about runtime encryption. So the VBS enclaves technology, it doesn't really encrypt the memory of the lower layer VTLs. So if you have a hypervisor level attacker, or if you have a physical attacker that can dump the memory, connect physically with probes to the memory and dump it, you will still defeat this feature. There is another technology that could raise the bar even higher. It's called confidential VMs. And confidential VMs, instead of relying on hypervisor, they rely on special hardware, like, for example, Intel TDX or AMD SCV SNP, or maybe some additional technologies. And confidential VMs, first of all, the memory of each VM, it's not only separated from other VMs and from the main OS, it is also encrypted. So even a physical attacker that will try to dump the memory, they will not succeed. There are some physical attacks that can still defeat this technology, but at least the most trivial ones, or maybe medium ones, you could mitigate. And some additional cool feature this technology allows is something called attestation, boot time attestation. So basically, if you could place the Speak For Me app inside such confidential VM, you could then use this attestation technology to implement a scheme called secure key release. So after the boot is done, Speak For Me application could request the underlying hardware to send attestation claims to some web service that secures the key for the model, such as, for example, Azure Key Vault. And what is attestation claims? So basically, attestation claims is a set of cryptographic data that is signed by the hardware, and this cryptographic data basically attests the versions of all the critical components running on this system, like the bootloader component, the firmware running on this hardware, and so on. So the Azure Key Vault would make sure those attestation claims signed by the expected key, and it will check the versions of the components that your machine is running, and if everything is good, it will release the model encryption key, and Speak For Me app could now load the model securely. So the main problem with this technology is that it is currently not available on general purpose PCs. This is something that is only available for data center servers mostly. So at least at this point of time, no personal PC supports this technology, as far as I know. And there is also one additional problem with this technology. So all the diagrams I showed previously on the couple of previous slides were intentionally misleading. I kind of placed this diagram entirely inside the secure mode, while in practice there is a front-end side of this whole application which lies outside, and front-end side is the graphical user interface and the peripherals that are used to record and to play the voice. And the attacker would simply, instead of targeting the secure part, the attacker would simply target the front-end side. They will try to manipulate the GUI. They will try to manipulate the peripherals. And this leads us to our second bigger problem. Up until now, we only discussed the model asset, but what about the voice asset? So there is no shortage of outside technologies that do pretty much the same as this feature does, except one part. They are not integrated as inside Windows infrastructure. So attacker, instead of trying to steal your voice model, they could steal your voice recordings and use external infrastructure without any mitigations and without any restrictions to train a model from your voice. And there are some open source and also commercial projects that require as little as 15 seconds of your voice to produce such digital copy. And Speak For Me app requires you to record voice samples to train the model. So to fully mitigate this problem, you need some specialized hardware, some specialized secure peripherals like secure camera or secure microphone. And there is also additional side of this problem, the opposite direction, the generated voice. So the watermark mechanism can be protected inside secure enclave, but not everyone has the SDK to check this watermark. My mom doesn't have the SDK, and probably if this model calls your bank over regular telephony, they probably don't have it either. So you can secure the watermark as much as you want, but as long as there is no one to check it on the other side, it is useless. And the attacker could simply target the graphical user interface and force it to produce any voice they want so that it will be unnoticeable to you. So again, to mitigate this kind of stuff, you need secure hardware, which is not part of general purpose PCs. So despite exceptional collaboration from the development team and their eagerness to fix all the issues, unfortunately, Microsoft, as I mentioned, has had to take the tough decision to abandon the feature. Our team did try to find some possible solutions, including even more exotic ones, such as, for example, releasing this feature only for limited set of devices or limited OS modes, like, for example, Windows S mode. And for those of you who are not familiar with Windows S mode, which is probably most of you, I also heard about it only when we reviewed this feature, and I was looking for some solutions. Windows S mode is basically a locked down version of Windows, which only allows installing apps from trusted sources like Windows App Store. And this would make it much harder for the malware to land on the device in the first place. But again, the consensus was that this feature could not be released on general purpose device, and it would just not be feasible for the general purpose devices. And this was the original intent, because this feature was supposed to be available and accessible for everyone. So Microsoft took the decision to not release it, but you can still use this feature via the custom neural voice service, which predates the Speak For Me, and it is available for selected customers that go through manual review process. Again, Microsoft cannot allow itself to do what open source models do or some commercial solutions. We have to be responsible, and that's why to use this service, customers have to go through some manual verification process. So I would like to go to the takeaways. And there are 3 takeaways from this whole work. So first of all, AI models are powerful, and with great power comes great responsibility. There are some really powerful, some AI models, some AI use cases, which can be, if not secured properly, can be used to either impersonate you on unprecedented level, like, for example, Speak For Me. There is another Windows feature which also was released, which was released like a year ago, called Recall, So again, if not secured properly, this feature could be used to extract and steal any of your sensitive data in a matter of seconds and to find efficiently, specifically what the attacker is looking for. So AI models are more than just another sensitive data. You need to take a dedicated approach, a dedicated threat modeling, and to take into account all the risks to secure them properly. Another takeaway, protecting AI on client devices, it is hard on general purpose devices. And AI, again, it is developing, it is advancing at meteoric speeds, and security does not necessarily advance at the same speed. We at Microsoft recognize that there is a gap here, and we work on many fronts to close this gap. We work on security features that are released as part of the Windows OS. We work on secure hardware. And by the way, many don't realize this, but Microsoft is also a hardware company, not only software company. And I'm not talking about Xboxes or Microsoft keyboards. I'm talking about things like, for example, security processors like Pluton processor, which we released a couple of years ago, and which was integrated into Surface and some other laptops. And the security processor raises the bar much higher for those laptops. We also work on AI development guidelines to help developers making the model safer and use a safer cycle of development. And last but not the least, we also have internal red teams, such as my team, where we take the proactive approach and we try to break features before bad guys do. But more importantly, we also try to fix them. Unfortunately, in some cases, like Speak for Me, the responsible approach was to abandon or postpone this feature, and this leads me to my final point. Today, most of the AI security is about keeping the bad guys out of AI models. But as AI gets more powerful and more agentic, we might want to shift the focus towards keeping the bad AIs in. And sometimes the most responsible approach is just to slow down and make sure that the model can be secured properly before it is released. Now it will be a good time for questions. Thank you.
Thanks. So you showed ways with the virtualization-based security to protect the runtime, but
Yeah.
So from my understanding, the DP API doesn't protect from, let's say, a malware that would be on the machine and could take the file that contains the model and decrypt it, right?
Yeah, it does not, because there is a different API that runs through VBS security. As far as I know, again, I'm not an expert on DP API, but as far as I know, today it doesn't go through the VBS trust set. So basically, it does. It would prevent you, if you're a user level malware, it would prevent you from taking over this mechanism, but I think if you run on admin level or on kernel level, you could defeat DP API during the runtime. And I mean, even, during the runtime mostly.
Yeah. So I think other OSs, like, there's ways to tie a secret to a specific application. I think macOS has like the keychain thing, and like in Android, you cannot access an app, like a secret from another app like, is there something that that's coming on Windows to do something like that, or are you aware? Or
well, again,
efforts
there is VBS stuff, and there is a feature. As far as I know, it's public. It's called Personal Data Encryption (PD) API. So it goes through biometrics, and biometrics is protected using the VBS technology. So yeah, you definitely have this stuff, but you have to remember that Windows is built by design for generic hardware, for generic machines, which do not necessarily have all the hardware security features like Mac has, because Mac is a closed infrastructure, or maybe, I don't know, some of the Samsung phones. So we have to deal with the fragmentation, and we have to deal with possible versions of Windows, and we have to support backward compatibility. But again, the additional, like I mentioned, you could put some of the parts of this application inside enclave, but the problem would still be with your voice. So if you could steal the voice, and I don't know, for example, if Mac OS has the technology to secure the microphone end-to-end. Maybe they do, again, because it is a closed hardware, a closed infrastructure. They control all the components. On Windows, you can connect anything you want on your machine. You can install a third-party driver. Again, it is this approach was done by design for Windows, and it has pros and cons.
Okay, so, thanks.
I hope this answers your question.
I thought your last comment about securing this local models for kind of future iterations is really insightful. What do you see as kind of the right platform or approach to doing this more generally going forward?
So if we talk about Windows specifically, I personally think that, again, you could take many approaches, but I believe that confidential VM is a good technology to go forward with. So there are a couple of ways you could do it even without specialized hardware such as TDX. There are some ways to do it using hypervisor as well. You would still need some kind of hardware that supports memory encryption, because you still have to encrypt memory. And also, maybe this can be combined with technology that would secure playback and recording of sound and video end-to-end. Some DRM, I mean, in fact, DRM technology already supports this, but I think it's only for playback, not for microphone, as far as I know. And DRM, I'm not sure it is supported on any hardware, and it provides you end-to-end encryption between the peripheral where you play your sound and the internals where the model runs. So it really depends. But I think the confidential VM is a good technology to go forward for securing AI models.
If you look at the trustlets and the hypervisor-based protections, are there also performance limitations? Because inference is pretty performance.
That's a good question. As far as I know, the only limitation I know is the development cycle. It simply means that because it is an isolated environment, you don't have all the SDKs. In terms of performance, I think, I mean, it's just another kind of software that just runs with different set of configuration and different bits controlled by hypervisor. So I believe it should not have any penalty. The penalty, you start to receive penalty the moment you start to encrypt stuff and start to move things around from one piece of memory to another. With this technology, since it is software-based, it is based on hypervisor, I believe it should not have much of performance penalty. By the way, regarding the confidential VMs, this is something that is already supported for securing AI on data centers. So many companies actually leverage this technology, not only on Azure, but on other clouds like Google and AWS. There are also versions of local CVM infrastructures. So it is just not available for personal PCs. That's the current limitation.
Thank you.
Okay.